Okay, folks. Well, what we'll tackle this time is just another practice sample solution for an old final exam question. Again, this one has been taken from the 2016 final exam since there weren't posted solutions for that one. And again, I'm going to tweak the question a little bit for the version that I show you, partly because the original question had some errors in it, and so I'll go through and point those out. Those were, corrections were given during the final exam for that one, but we'll talk about that. And I changed the nature of the answer you have to give just a little. So we'll talk about that in just one tick here. So again, the revised version of the question. So the idea is you're being given a grammar for a language. So we've got this set of grammar rules where we're going from a top-level statement that's a program. So our programs have a begin, a statement, and an end. Statements are essentially assignment statements, variable name, the colon equals as the assignment operator, and then an expression, and then a sequence of rules to describe what are valid expressions. So an expression can either be an expression and then the hash and a sub-expression, or it can just simply be a sub-expression. So this was one of the corrections to the originally posted question. The sub-expressions can have either of two operators, so it can either be a sub-expression, the dollar or the question mark, and then a value, or a sub-expression can simply be a value. And values can either be variables or quadints. Quadints are essentially single digits that are either 0, 1, 2, or 3. So just made up a data type for this. So we've either got 4 possible variables or 4 possible integer values, 0, 1, 2, or 3, as the only things that we can compute in our expressions here. So if this was our grammar, then the question was to go through and say, okay, you're given something that's supposed to be a program in this language, and we're supposed to show a derivation for it. So going from program down to this, show how you get there. And also we're supposed to go through and describe the precedence and associativity rules for the 3 operators we're given. So there's the revised question. So I'm just going to work out a bit of a sample solution here. So I'm going to go through and do the precedence and associativity first, because I can just get that from straight looking at the grammar rules there. Precedence and associativity. The hash operators, if we take a look up here, we've always got expressions are this is the only thing that can derive our hash symbols. Once we get to sub-expressions, we can never go back. So these hashes always have to be derived first. So they're going to be higher in the parse tree, which means they're a lower precedence. Must be derived. So I'm just going to write that down. Derived first, higher in the parse tree, lower precedence. Well, the other 2 operators can come later on. The dollar and the question mark are of equal higher precedence. So first part of that, we can go through and say, okay, well, I know that the hashes have lower precedence than the other 2. So are we doing this right to left or left to right? Well, again, we can see this from the way these things are laid out. When we're going through and deriving something, we're kind of getting the leftmost version of the expression first, and then diving down to subsequent ones. So if there's multiple hashes in here, we're getting the leftmost one first, and then going on to get the ones that are further down on the right-hand side. So that means the one on the left side is highest in the parse tree, and it's lowest, or essentially the last one done. So it's got to be doing these things from right to left. Or pardon me, from left to right, oh my god. So, and it's going to be the same thing with our dollars and our question marks here. The rightmost dollar sign is going to be the last one evaluated. Right? The ones that are further to the left are going to be further down the parse tree, therefore they're going to get processed first. Right? So this is processing from left to right, and the same thing with the question mark. So it's going to go through and do the dollars and question marks from left to right as the first order of business, and then do the hashes from left to right as the second order of business. So let's see if we can write that out a little bit. Oops. What have we done here? So the associativity, or the, let's say the operations of equal precedence are done from left to right. Again, since we can see in the rules that the left or the rightmost operator is the first one derived, highest in the parse tree, and last one to actually be processed. So we've got half of the question done there. So as far as the derivation goes, we're trying to get from this original program rule down to this eventual expression. So what I'm going to do is, here I'm going to say I'm going to show the non-terminal we're deriving or we're processing at each point in the derivation. Just because I suspect that my derivation is going to get fairly unwieldy to describe otherwise. So we're starting off with this, starting off at the beginning. We've only got one rule for the program, so that's got to be the first one we do. So we've got to start with that program rule. And then from there, we've now got begin, statement, end, right, which matches our begin, a bunch of stuff, and end. And we've only got one kind of statement. So it can only be, our statement has to go, well, I might as well just cut and paste this. Let's make life easy here. So it's got to be the case that our statement goes to a variable, an assignment operation, and an expression, which again matches what we've got going on here. We've got a variable, an assignment operator, and then some expression. So it should be pretty clear that our variable, again, I might as well just cut and paste, huh? Our variable is x, so we're just applying that rule to get our x. And so now we've got everything except this ugly piece of expression here. So now that's what we've got to derive. So our expression can only go one of two ways. Our expression can either be, it goes to an expression, a hash, and a sub-expression, or straight to a sub-expression. Well, we've got a hash symbol in there that we've got to derive somehow, so we've got to be doing this one next. So it's got to be this one next. And then we've got our two halves of this that we can really kind of process in either order. We've got the stuff before the hash, so this expression has got to go to the $3x eventually, and the rest of it has got to go to the y, question mark, z, $2. So we can do whichever one you happen to like. I'm going to show the sub-expression next, so the stuff on the right side of the hash. So we've got our sub-expression. Now here, we've got a bit of ambiguity going on because we could do either of these two things next. Do we have one of each on the other side? We do. We could either do the question mark derivation next or the dollar derivation next. If we do the dollar next, it's got to be a value on the end. So, oh no, we're good. So we have to wind up with our 2 on the end, right? So the 2 has to go to the value, and the thing before it is the dollar. So it's got to be this rule next for that sub-expression. So then we can get our value going to the 2, or our value going to the quad int, I guess, and the quad int going to the 2. Right, so now for the sub-expression that we have here has got to boil down to this y question mark z. So let's get our sub-expression. Now has to go to a sub-expression with a question mark in it. Right, and then the value for that one. Oops, that's not going to be right, is it? So we've got our y question mark z, so that's got to go down to a variable. Right, the value on the end there has to go to a variable, and that variable has to go to our z. Right, so now we've got essentially this part done, and we've just got to get that out of our sub-expression. So what have we got here? Oops. Yeah, knock it off, Dave. So our sub-expression now has to go to a value. That value has to go to a variable. And that variable has to go to y. So what have we got now? So we've gone through, and I think we've now got everything that was on the right-hand side of that hash. So now what we've got left is that the expression part that was before the hash. So our expression has to go to something with a $sign in it, which means that we've got to use this expression goes to sub-expression and then get the $sign out of that. So that expression that we still have left, we want it to go to a sub-expression. We want the sub-expression to capture the $sign. And then what have we got on either side of the $sign? We've got an X after and a 3 before. So the what do we have there? So our value has to go to a variable, which has to go to X. And so we'll just grab all these pieces. So now we've got everything except the 3 at the beginning. So we've got our sub-expression that was on the left side of the $sign. We've got to get to go to a value. The value has to go to a quad int. And the quad int has to go to our 3. And there we have it. We've gone through, identified one piece to expand in our derivation at each point, and we've managed to capture everything in our expression. Lots of fun. All right, I will leave that one there, and we'll see what we can come up with next time around.